In this exercise, we're going to be learning how to find a cross product, a dot product, how to sum vectors, and even a scalar product. So there's a lot going on in terms of vectors with this question, so it's kind of a good one. And perhaps the first place that we want to start is the easiest concept to understand. So when we look at this operation, this set of operations, we can look inside of the second parentheses and we can see that we actually need to be working with 4 times d2. So this is what's called a scalar product. And all it means is that you take the vector marked d2, so that would be this vector right here, and you just multiply every component by 4. So we'll end up multiplying this -5 by 4, this +2 by 4, and then here we actually have a -1. We would multiply that by 4 as well. So we'll go ahead and do that. That would give us 4d2 is equal, and again, we just go and multiply everybody by 4 there. We're going to get -20 I hat, and then we're going to add 8 j hat, and then that's going to be -4 k hat. Now those are just x, y, and z components of the vector. So the x component would be -20, the y component would be +8, and the z component would be -4. So those are 3 components of this new vector that we just created, 4 times d2. Now, the next place to consider would be the cross product. This might be the most challenging. So we're going from the easiest to the most challenging, but that's okay. We can do this. We're going to be crossing vector d1 and the vector that we just generated, that 4d2 vector. So it's a cross product. We're going to set that up as follows. We're going to do this very carefully. We're going to create a little chart, a little table, and in that chart we're going to be listing the I, j, k, also known as x, y, z, components of each vector. Now, vector d1 is first in the cross, so we're going to list that first. And then comes vector 4d2. So all we're doing is listing the I hat, j hat, and k hat, x, y, z components of these 2 vectors. Now vector d1 is this vector right here. We can see that the components are 3, -2, and 4. So we just do 3, -2, and 4. And then for the vector 4d2, we just figure that out. Those are the components right there. So we'll list those, -20, and then 8, and then -4. Now it's time to actually do the cross product. This is where things get interesting. Let's just kind of shift this over a bit. We're going to actually do the cross product. And to do that, I like to set up a little template. And in that template, I draw a large space here, and I'm going to mark that I hat. I then put a minus sign next, always a minus sign. We'll draw a large line here, and we're going to mark that j hat. And then we're going to put a plus sign, always a plus sign there, and that will be, as you probably guessed, k hat. We'll try to make sure we fit this here. I, J, K. I do know my alphabet. There we go. Now we're going to fill in the first space there, the one next to the I hat. And to do that, we actually will cover up the I hat column. So if you're dealing with I hat, you cover up the I hat column, and then you're left with an array of 4 numbers. It's a little 2x2 array. What do you do with those 4 numbers? Well, you actually find something called the determinant, a frightening sounding thing, but it's really easy. All you do is cross multiply this way. So -2 times 4 would give me 8. We'll fill that in right here. Then you cross multiply the other way. That gives you 32. 8 times 4, 32. And then you subtract those 2 outcomes. You will always subtract. So that would actually give us -24. Why don't we just go ahead and write that in as -24 for convenience. So that's going to turn out to be the I hat, or the x component of our cross product. Next, we are going to fill in the space with the j hat, and that means we're going to cover up the j hat column. And then we just do our little determinant procedure. It's just really cross multiplication. So you're going to multiply 3 times -4, which is -12. And then you're going to cross multiply in the other direction, so that way. So 4 times -20 is -80. Now be careful here, because remember, you got to subtract those. So we're getting kind of crazy here with parentheses, but we're going to subtract those two outcomes. Always subtract, so negative 12 minus negative 80 is 68. So this whole space here is going to be 68. And that completes the j hat or y component. Now we'll fill in the k hat. You guessed it, we're going to cover up the k hat column, and then we're just going to cross multiply. So 3 times 8, 24. Let's cross multiply in the other direction. Negative 20 times negative 2 is 40. And then you'll subtract those two outcomes. So 24 minus 40 is negative 16. There we have it. Now let's just kind of collect our thoughts here. What is this again? Well, this is that cross product. So we'll write it down. So the cross product of vector d1 and the vector marked 4d2, that vector, that cross product is now, if we look at our outcome here, we're going to have negative 24 I hat minus 68 j hat. And then, be careful here. You're adding a negative. So that's just minus 16 k hat. Neat. That was that second set of parentheses. So kind of put that on hold. We're going to come back and continue working with that. But let's just go back up, clean up our little mess that we made, and see what else we need. We just figured out that cross product. That's nice. Let's look at the other set of parentheses. Now, here you're adding two vectors. You're doing d1 plus d2. And perhaps we could have done that earlier, but the good news is we got the hardest part out of the way. So vector d1 plus d2 is what we're going to come up with next. Now, when you're adding vectors in unit vector notation, it's a pretty straightforward procedure. All you need to do is combine like terms, essentially. You're going to add the I hat components together. So you're going to add 3 and negative 5. That would give you negative 2, and that'll be I hat. And then you're going to go ahead and add the j hat components together. Now, those will actually cancel. They'll become 0. We'll still write it in. We'll say plus 0 j hat. And then we'll combine the like terms here, the 4k hat and the negative 1k hat. That's going to give us a 3k hat. So that's plus 3k hat. Cool. Okay, so that's the second set of parentheses. And now what we have to do is we have to perform the dot product with these two vectors. So why don't we grab these vectors, kind of get them nearby, and then we're going to do the dot product of them. So there's that first set of parentheses, and then I suppose we can just copy paste the second set of parentheses. We'll do it right underneath, and we're just going to do the dot product. So here comes the dot product. We're doing d1 plus d2, little vector symbols above them, dot d1 cross 4d2. Okay, so this is the punchline. Now, when you're doing a dot product, again, it's relatively straightforward. A dot product simply asks you to multiply the x components together. So you would multiply negative 2 by negative 24. And then to that, you will add the product of the y components. Now there it's going to be 0 multiplied by negative 68. So that's really just going to be 0. 0 multiplied by anything is 0. And then finally, you guessed it, you're going to multiply those z components together. So 3 times negative 16. So now we can just process this calculation. It looks like you're going to get 48 plus 0 minus 48. And, well, that's interesting because that just equals 0. So let's make sure we've answered the question because that seems very anticlimactic, or climatic or climactic. I think it's climactic. And that is all they wanted. They wanted the dot product. So we are done. We have solved it. The answer is literally just 0. We did all that for nothing.